Good day, viewers. In this video, I want to differentiate x to the power of x. In differentiating x to the power of x, the first thing I should do is to represent this with y. And representing this with y, in order to move further, I'll take log of both sides to a certain base. It now depends on you, but I prefer taking log of both sides to base of e. That's log to base of e. It's easier to differentiate any function. Yeah, maybe sine, or maybe trig function, exponential function, linear function, quadratic function. So far the log is based to e. It's very easy to differentiate because you differentiate the function and you use to divide the function, and the function divides your derivative. Simple. So I'm going to say y equal x to the power of x. If y equal x to the power of x, take log of both sides to base of e. I have log y to base e equal log x to the power of x to base of e. And from here, I can write this in terms of ln. I can say ln y equal ln x to the power of x. Now applying law of logarithm, don't forget ln, let's say ln e to the power of p. This is same thing as p ln e. And don't forget ln e is 1. This gives you p. In case you have ln, let's say 2 to the power of p. This gives you p ln 2. The p, the power comes to the back as multiplier. That's what I'm going to do here. So therefore, I have ln y equal x ln x. Here, I have a logarithm function. Here, I have two functions. One is linear. This is linear. The second one is logarithm. So when differentiating this right hand side, I'm going to apply product rule. Differentiating the left hand side is straightforward, just differentiating logarithm. Let me write a simple logarithm and differentiate it in order to recall. If I have log x squared plus 1 base of e, and I'm trying to differentiate this, I'll differentiate this. The answer I'm going to get will be the numerator, and the denominator will be the whole of this. That's how to differentiate that. It's simple. I'll say derivative of x squared plus 1 with respect to x divided by x squared plus 1. Instead of applying chain rule, this is fast. So this is 2x over x squared plus 1. That's the shortcut to this. It is allowed in Cambridge examination. Now, don't forget also, if you are differentiating y, derivative of y with respect to x is the y with respect to x, and that's what that will be if you're differentiating y. But you have ln y. If you're differentiating this gives us 1 over y, the y with respect to x. That means the y, the x divided by y is still the same thing as saying 1 over y. Now, on the right hand side, I'm going to use product rule. The right hand side, I'm using product rule. Here, I have this. Don't forget product rule that you have u, derivative of v with respect to x, plus v, derivative of u with respect to x. Now, this is the interpretation of this. You are holding on one function, differentiating the second one. You interchange it. Hold on the second one, differentiate the first one. That's the meaning, which implies that I will hold on x and find derivative of ln x with respect to x, plus I'll hold on ln x and differentiate x with respect to x. That's what I'm going to do. So this gives x dot 1 over x plus ln x multiplied by 1. So this cancel this. I have x plus ln x. That's the derivative of the right hand side. So I'm going to substitute all what I've gotten into the answer of both sides. The left hand side I said is 1 over y dy with respect to x, and the side I said is 1 plus ln x. Now, I can't leave my answer this way. I need to get rid of this. Therefore, I multiply both sides by y. Y multiplied with 1 over y, derivative of y with respect to x. Y multiplied with 1 plus ln x. This cancel this. I have derivative of y with respect to x equal y multiplied by 1 plus ln x. Don't forget, this is not the final answer to this question, but we are very close. I need to write my final answer in terms of x, so which implies I need to get rid of this. And I represented y with x to the power of x. So let me clean this side and write my final answer, or I can just lift it up. So I represented y with, don't forget from the beginning, I said y is equal to x to the power of x. So if I'm writing my final derivative, that's the y dx is equal to x to the power of x, open bracket, to 1 plus ln x.